So today we're going to be talking about a pretty interesting topic, and we're going to continue our discussion of science on Friday as well. Science is a really interesting topic. A lot of people have ideas for what science is, what science isn't, and there's an entire subfield of um, philosophy called philosophy of science that kind of addresses a lot of these questions in science. Like, what is science? What is the scientific method? What is the scientific claim? What separates science from pseudoscience? Which is kind of like our big topic for today. How do you draw the line? How do you demark science on one side and pseudoscience on another side? It's not an easy question, honestly. Like, we all know some things that are pseudoscientific. That pseudoscience means something that sounds like it's science, kind of, but isn't. Its beliefs don't come from science. When you show people who believe in a pseudoscientific thing evidence that they're wrong, they don't accept it. But we'll talk about how you draw that line in a little bit. It's a really interesting field, though. I took a philosophy of science class. I don't think it was titled that exactly, but it was a philosophy of science class in grad school, and very interesting stuff. I learned a lot from it. It was actually very helpful in my job as essentially a scientist. I did research. I still do research, um, and it's also just really useful in real life, because in real life, people are going to be coming at you with pseudoscientific claims all the time. For example, you go to the grocery store and you're going to buy some shampoo. Shampoo is just full of like all these kind of ludicrous and obnoxious claims, like um, it's just soap. Like, they're just selling you, various forms of soap, and they're like, oh, for lustrous, luxuriant hair, you must use this shampoo or Pantene Pro V. It's a shampoo that contains provitamins to make your hair healthy. And it's like, the hell is a provitamin? I know what a vitamin is. A provitamin, at least in biology, is something that is like, in the chemical chain upstream from a vitamin that turns into vitamin. I have no idea how that's supposed to even work with hair, because it's not in your bloodstream. Like nothing about it makes any sense. I love going off on Roblox telling people astrology isn't real. Yeah, astrology is like kind of the classic example for pseudoscience. It kind of sounds a little bit scientific-y. Um, but no matter how many times you give scientific evidence showing it doesn't work, they still believe in it anyway. Okay. So what do you guys think? What is science? Like, what makes science science, and what makes, let's say, English literary criticism not science? Let's get some audience participation here. So we all you get a master's in science and biology. You get a master of fine arts in literature. Why is one called an art and one called a science? Did you guys come up with some definition of science that would allow us to categorize physics as a science and literary criticism as not science? Pause it now. Okay, we got some good answers here. We got the Bill Nye science falls back on evidence to back up claims. Yeah, but so does literary criticism, right? Like, when I wrote a literary criticism paper on A Tale of Two Cities by Charles Dickens, like, I used evidence, right? I said that Madame Lafarge, I think her name was Laforge. No, that's Star Trek. Like, when she was sewing all the time, I said she's sewing, in essence, the French Revolution. And like, I provided quotes from, the book to like back up my claims. I had evidence to support my claims, and in fact, basically in every college discipline worth its salt, you are going to be making, claims supported by evidence. That doesn't make it a scientific claim. It doesn't mean that what I was doing was science, but when I was doing literary criticism of Dickens, like, I was like, you can't just make things up, right? Like you point to things in the book, like on page 73. You know, the thing here is something that supports my thesis. So science is observation, measurement, and experiment. Okay. Um, not all scientific fields do experiments though. Like if you're studying black holes, you don't have the ability really to uh, do a direct experiment on it. You can do observation certainly and measurement certainly, but experiment, you just kind of have to like look up at the heavens and try and find a black hole and observe it. You can't directly put it into a test tube. Um, it's a tricky question actually to define exactly what science is. A knowledge uses experiments to prove a study. Again, experiments. Not all forms of science can do direct experimentation. Um, Science deals with our natural world. I would actually disagree with that because computer science is a science, even though that's controversial. Also, like, is computer science science? It's controversial. Like a lot of people consider computer science more of an engineering discipline, right? Because we're building programs. But that's kind of a limited view of what computer science is. Computer science is at a higher level, like a study of a man-made product, a computer, and finding out what makes some programs go faster and some go slower, and how to architecture computers so that they work better and things like that. So yeah, you can study man-made products. You can study people, even, which is a man-made product technically. So it doesn't have to be like the natural world, so to speak. Study of a philosophy, I wouldn't say is close enough. Yeah, science is knowledge. I would, yeah, like, I mean, literary criticism is knowledge too. So having expertise, I don't know. You can have expertise in literary criticism too. It's a tough question. Okay. So, science is the study of all living organisms. Yeah, no, I'd say it's more than just biology. There's chemistry and geology, which is a rock. It's not a living organism. Okay, it'd be best if you had a hypothesis and proved it. This is more like the scientific method. I mean, in literary criticism, I had a hypothesis about the sewing indicating that she was making the French Revolution, and I feel like I proved it pretty well. I don't know. So it's a tough one. It really is. And so, what is the scientific claim? Is it a claim about reality? Is it a true claim about reality? Verifiable claim? And so a lot of you guys were using verification sort of as your criteria for science. That if I give you a claim such as ice forms at 0 degrees Celsius, right? If you take water and you put it in the freezer at 0 degrees Celsius, ice forms. That's a scientific claim. I think most people would generally agree that's a scientific claim. But what about it makes it a scientific claim? The fact that you could do it yourself, like you could take water and put it in the freezer and see that it freezes and forms ice, or is it something else? And so that question of like where you draw the line, like what about a scientific claim makes it science and not pseudoscience? That's a big question, right? So the line between science and not science is not, it's not necessarily as easy as you would think, right? It's like, I would argue that like literary criticism actually shares a lot of things in common with science. Sure, there's no experimentation. So maybe that's the difference. You can't put A Tale of Two Cities into a test tube and shake it up and be like, oh, yep, there it is. Madame Lafarge. What is her name? Is it Lafarge? Defarge? Defarge, not Lafarge. Okay. Yeah. All right. Defarge seal. Okay, symbolizes several themes. She represents one aspect of the faith. See, this is literary criticism, right? The more I use yarn to measure out the life of a man and to cut it, Defarge knits, and her knitting secretly encodes the names of the people to be killed. So, like, that's, they're making an observation about a book in the real world, but there's no real experimentation on it. Like, other people can look at the book and come up with a different conclusion, like I did, I didn't come up with the fates or whatever. I had my own, like she was plotting, and the knitting represented the threads of the revolution coming together. Defarge, not Lafarge. Math, you're not really doing observation of the real world when you do math. A lot of people get confused on that point. Because like when you're in elementary school, like you're like, okay, if you have 2 apples and 2 apples, now you have 4 apples. But very quickly you move beyond like math as like observation of the real world. Like my daughter started crying when I explained negative numbers to her the first time, because she was like, you can't have negative apples. It doesn't make sense. And I'm like, well, you have to think of it like owing somebody an apple or something like that. And then, this last weekend, I'm like, all right, Ada, if you have a pizza that has -6 slices on it and you invite -3 people to your party, how many slices does each one of the negative people get? And she's like, 2. And I'm like, you're right. And she's like, right. Like math very quickly like leaves the realm of like, empiricism. Okay. And so math is generally held to be not science, right? You're doing a rational activity in your head. It's a priori. It's not a posteriori like sciences. Now, the tougher question is the line between science and pseudoscience. Like, so aromatherapy is a set of claims saying, like, if you play, not play, but like, yeah, let's say you put oil onto like a diffuser and you like spray lavender oil through the room, that this will improve your ability to do homework or something like that. Or if you put chamomile oil onto your diffuser, then that cures your cancer or something. I don't know. Does that sound like science to you, or does that sound like pseudoscience to you? So pseudoscience, again, is something that kind of tries to have the trappings of science, but it hasn't really like gone through the scientific method. It's not really based on scientific studies. It's more based on people making things up. Another feature of pseudoscience is like when you give contrary evidence that they don't accept it. Whereas in science, if you give somebody contrary evidence, they're like, oh, I must change or revise my beliefs. But in pseudoscience, they just sort of ignore contrary evidence. So does anyone ever get these confused, astronomy and astrology? You ever like say the wrong one sometimes? Do you guys know what the difference is between astronomy and astrology? Answers now in chat, please. Okay, so yeah. So astronomy is the scientific study of the heavens, right? You're like, oh look, there's a cool supernova, and then everyone like trains their telescopes on it, and they like make recordings, and they, the MythBuster definition of science, by the way, is you writing stuff down, right? You make an observation, you write it down. That's what makes it science. So astronomy is like classically, like in philosophy of religion, like these are like, if anything's a science versus pseudoscience, it's astronomy versus astrology. Astronomy is the scientific observation of the heavens. Astrology is the belief that where Jupiter is will cause you to win the lottery, right? Which has kind of like no basis in reality. No matter how many times you do a survey, like just think about it. Like if Jupiter's location caused you to win the lottery based on the month in which you were born, then the lotteries would see 17 Geminis win the lottery all at the same time, all the time, right? Like every time like a bunch of people hit the lottery, they'd all be Capricorns or something, right? Or more it's just there's no basis. And no matter how many times like you can disprove it, there's always an excuse for it, and nobody ever seems to ever adapt their ideas to reality. So that's a crucial feature of pseudoscience. It's like you can't disprove it. Yeah. So astrology is about motion and property of events on Earth. Well, I see. Things outside the Earth. Yeah. Well, no, astrology is like observing the stars to find out what's going to happen on Earth in the future. Yeah, or something. It already feels like that. So aromatherapy, you could probably design scientific studies to test it, but as far as I can tell, like most of the claims in aromatherapy is just somebody sitting down and just writing up they feel like. So aromatherapy, I'd also say, is pseudoscience. Okay, so a lot of you guys were mentioning experiment as like the core feature of science. That was like probably the most common response, and so that comes to the notion of verifiability. Verifiability means that if I give you a scientific fact, you can run the experiment and verify that it's true. But Karl Popper, and not everybody agrees with Popper, by the way, but you will hear this belief all over the place in science. Karl Popper actually said, no, you guys got it backwards. What makes something science is the fact that a scientific theory is falsifiable. You can prove it wrong, in theory. Like if you do an experiment, you put water into a freezer and it doesn't freeze, then you're going to have to go back and you're going to have to revise your statement. You revise your scientific claim. For example, maybe there's a lot of salt in it or something, right? And the freezing temperature is lower than normal. And so that, he believed, is sort of the fundamental line between science and pseudoscience, is that at least in theory, you can do an experiment that would show that like gravity is not real, right? Like you can take your cell phone and drop it and and be like, oh, it didn't fall today. Gravity's wrong. Like falsifiable doesn't mean that it's false, because everybody seems to think gravity is real, and so far so good. Every time I've dropped my cell phone, it's fallen and oftentimes broken the screen. I went like 10 years without ever dropping a cell phone and cracking it, and then I got an LG phone that had like a glass backing on it, and I like put it down on a table and it just slid off and fell and cracked. I had to replace the glass on the thing like 3 times. So gravity is pretty, like, I'm pretty solid on gravity. Like, I'm pretty sure it's right. But like in theory, like you could do an experiment and you drop something and it doesn't fall, right? You're like, oh, okay, it's been falsified. So falsifiability doesn't mean false. All good scientific theories, according to Popper, are falsifiable. That doesn't mean they're false. It just means in theory you could show that it's wrong. Whereas with astrology, it doesn't matter if you look at the predictions, for tomorrow, and they say, oh, tomorrow's a great day to go look for a job. You do an experiment, you get people from all the 12 different zodiac signs, and you don't see any effect at all from Jupiter being in the 3rd house of Orion or whatever, when you come up with the disproving evidence, you falsify the theory. People in pseudoscience are like, oh, well, the Mars was in the 2nd house of Aries or something. I don't know. They always have like some excuse why it didn't work. They don't change their mind. They don't reject the theory. That's kind of what makes it pseudoscience. And a lot of times it's vague. It's so vague that like they, if you say this didn't happen, they kind of goalpost shift over here, or they just don't accept, the data. So yes, like penicillin kills all bacteria is a claim that could be falsified. In fact, it is false in this case, because penicillin does not kill all bacteria. There's like gram-positive and gram-negative, and there's penicillin resistant bacteria and all sorts of things it doesn't kill. So you do an experiment and you're like, oh, look, it didn't kill it. And then you reject your theory. That if you're a good scientist, you're like, okay, I'm going to have to reject my theory that penicillin kills all bacteria. I was too optimistic. Here, let me revise it down to something, more based on the new facts. However, like Kuhn doesn't agree with Popper. Thomas Kuhn was probably the most famous philosopher of science. He said essentially what demarks science from pseudoscience is the puzzle solving nature, right? Like as evidence comes in, like scientists are actively working to like figure it out, right? Like the COVID-19 origins, right? Like there's data coming in, they're like, okay, the COVID-19 virus cleaves to the furin site. We don't see that in nature. So is that a lab leak? Maybe, I don't know. And then China's like, here's some DNA from pangolins. Like, oh, look, the pangolin viruses exhibit these 6 things that we saw in COVID-19 for the first time. And that's a natural origin. So maybe it's a natural origin, and they were like kind of like going back and forth on it. Like, The Intercept released a bunch of FOIA, Freedom of Information Act emails from like Fauci and other people. And I've been going through them. It's very interesting to see like how they were like working out, trying to figure out, is it a lab leak? Is it, Was it bioengineered? Was it a lab leak? Was it like a pangolin at the wet market, or did it cross over into another species? And like they're sitting there and they're trying all these different hypotheses, and you can see them just actively like solving a puzzle, And what Kuhn says is that with pseudoscience they don't do that, right? Like you do an experiment and you find out that Jupiter has no effect on your love life at all. Like they don't go like, okay, well we need a new theory now. They don't do that. Like when you have pseudoscience, they're like, okay, cool, thanks for the negative result, and they just don't. They're just not actively working to solve like how exactly Jupiter can cause you to get a date. So true and false and falsifiable are different concepts, right? True versus false is like the statement that water freezes at 0 degrees centigrade is arguably false, because you can actually put, like I said, salt into water and have it freeze at a lower temperature. But that's not the question we're talking about when we're talking about falsifiable. Falsifiable means you could run an experiment that, at least in theory, will give you a negative result, and then you have to revise your theory, right? It's like you can shoot electrons at a gold foil, and it scatters, and actually, a great example would be, CERN was sending things at the speed of light to the Gran. It's not Gran Turismo. What was the name of the laboratory? Italy Science Gran Sasso. That's it. Not Gran Turismo. Completely different. So CERN was sending, I guess, photons at the speed of light to Gran Sasso, and Gran Sasso was actually measuring the things arriving faster than the speed of light. And if that was true, it turned out to be a measurement error. But if that was true, then all of what we believe about like relativity and like there's this global speed limit that nobody can break, would have to be thrown out. That's what it means for a theory to be falsifiable. Like, even though we're pretty sure that the speed of light is like our galactic speed limit, so to speak, even though we're pretty sure about that, if that Gran Sasso result had been true, then we'd be like, all right, throw it out. It's been falsified, So there are lots of scientific claims that have been falsified over the years, too. The luminiferous aether is this notion of like a lattice through which light travels. Turns out life is self-propagating. Phlogiston is like the essence of fire, the element of fire, sort of. A mysterious substance that causes fire to take place, essentially. Newtonian physics has been falsified. It's wrong at high speeds. It's been replaced with Einstein's relativity at higher speeds. At low speeds, it works fine. The notion that humans only use 10% of their brains. I don't know if you've seen the Morgan Freeman, 10%, 100% brain meme. So like there's what if you use 100% of the brain? Yeah, that's the interesting. Yeah, there's a whole bunch of memes for this. Yeah. He's seen a water bottle to fill the water bottle. That's amazing. Yeah, like there's just a whole bunch of persistent urban legends, like humans only use 10% of their brain. It's complete nonsense, right? Like there's not like this massive untapped potential in your brain. We don't use 100% of our brain at once, because that would be horrible. Every neuron activating at once would like a seizure, I think. But yeah, like there's a lot of like scientific claims we've rejected. We don't believe them anymore. So based on the falsifiability criteria, falsifiability criteria means that if you got a negative result, that you would reject the theory, right? And so take a look at these, and I'd like for you guys to categorize them: science or pseudoscience. Begin. All right, and we're back. All swans are black. Yeah, that's a falsifiable hypothesis. You go out, you do an observation of swans, like, oh, there's a white one. It's been falsified. It's false. That's the scientific claim. Pizza is delicious. Now that's a tricky one. It's opinion, but science can work with opinion. You can go out there and poll people and be like, hey, do you think pizza is delicious? And, if 80% of Americans say pizza is delicious, you'd be like, oh, okay, it's delicious, I guess. And then, if 80% of people say it's not delicious, right? Okay, it's not delicious. So I'd argue, it's sure. Like, a lot of people are confused, like, oh, it's opinion, it's not fact. But it's like, we do studies, we work with people's opinions, like, who do you think's the best president, or do you approve of the president? Like, those kinds of polling questions are scientific, even though it's working with opinion. Salt dissolved in water, sure, you can run an experiment, you try dissolving salt in water, hey, look, it did, cool. Now, just because you verified it once doesn't mean that it is necessarily true. In science, we have things that are kind of shown to be false and things that are sort of conditionally true. And maybe you keep adding salt to water and then it stops dissolving. You're like, oh, it's saturated now, so maybe it is false, you falsify the thesis. A lot of it also just sounds like science, right? And so you want to not get too caught up in the fact that I'm using like scientific terminology and things like that, because there are people who do pseudoscience that are quite good at it, and they use all these like scientific terms like pentawater, which I'm embarrassed to say that I bought a bottle of it. Pentawater uses ultrasound to vibrate water and form pentagons of water in the water, and supposedly when water is in a pentagon shape, it hydrates your body 300% faster. And I was reading this label, I'm like, that is the biggest BS I've ever seen in my life. But I was curious to see if it tasted good, and it actually did. And I still feel guilty about it because I was like directly supporting this like kind of pseudoscience nonsense. But it was pretty good water. The FDA actually made them change their labels because like it was just blatantly false advertising. Like, water does not assume the shape of a pentagon when you vibrate it with ultrasound, and even if it did, like, it wouldn't stay in a pentagon shape for more than like a nanosecond after you stop vibrating, because water is chaotic and will move around. Omega-3 fats help prevent heart science. I would say so. Omega-3 fats prevent heart disease and stroke. Sure, you can test that. There's a hypothesis. Control group, experimental group. Give the control group omega-3 fatty acids, and see if they get more heart attacks after 5 years or something like that. Yeah, sure. That is a falsifiable hypothesis. The next one, though, good night's sleep is important for physical and mental health. Trouble with this one, the trouble that I have here is like it's not defined very well. Right? So like, okay, I'm sure a good night's sleep is important for your health, but like, what are you talking about? Are you talking about lifespan? Are you talking about blood pressure? Are you talking about weight? Because like people that get better night's sleep tend to lose weight easier than people that are sleep deprived. What are we talking about here? And so like if you did a study, you're like, oh look, people that didn't sleep well, their blood pressure is the same as people that did sleep well. Did it disprove this hypothesis? No. Why? Because the terms are vague. And so I would say that one is actually like pseudoscience, even though, because you can't really disprove it. Like, what does it mean? Health and mental health. It's like when you talk about the economy. The economy is bad right now. How? Like it's such a big topic. It's such a big topic. We're talking about the stock market. We're talking about unemployment. Are we talking about inflation? What are we talking about? So this is a better way of writing a scientific claim than this. Procrastination is caused by lack of self-regulation. Yeah, I've seen papers along those lines and psychology papers and things like that. Your zodiac sign influences your behavior. That's astrology. So pseudoscience. People collect things because they're lonely. I've also seen this in Psychology Today, which is not a great science journal website. So I don't know about that one. That one's dubious to me. All right, so here we got some more. Vaccines cause autism. So this is a classic pseudoscience example, because there was a paper, 20-ish years ago by a guy named Wakefield that purported to show that vaccines cause autism in kids. and got a lot of traction. Turned out the study was badly done. It was actually retracted. But to this day, people still believe that vaccines cause autism, despite the fact that there have been numerous studies showing it's not true. And so that's a classic example of a pseudoscientific belief, where no matter how much scientific evidence comes in on a topic, they will choose to believe whatever they want anyway, right? In other words, you can't falsify this. You come out with this negative result, like it doesn't cause autism, and they like ignore it. And so that's a classic way of telling if something is pseudoscience. It can't be falsified. You can't prove them wrong. Okay. Acupuncture can reduce pain. That's science, actually. Even though it's even though like if you go on to like Wikipedia, let's say, I think that they have it classified as pseudoscience. Yeah, acupuncture is a pseudoscience. Like it says so right there on Wikipedia, right? And so the conclusions and trials and systematic reviews of acupuncture generally provided no good evidence of benefit, which suggests it's a non-effective method of healthcare, generally safe, properly delivered, low rate of things. Reports of infection are increasing. There is no scientific basis for qi and things like that. However, you can do a study to find out if it reduces pain or not. And so the way they tested it though was by using sham needles, where like they hit your skin, but it doesn't actually go in, right? And so basically, what they found was that the pain relief from acupuncture is due to the placebo effect. So the trouble is like the placebo effect is real, right? Like it's not like the people are lying about it. And so, like you can study this question scientifically if it reduces pain, even though acupuncture itself is described as pseudoscience because the results are, not, there doesn't seem to be any good scientific basis for it, but you can study it. Like you can make a scientific question like this. So, power posing or other ways standing with good posture increase your self-confidence and physical health. Yeah, it may or may not be right. It may be true, maybe false, who knows? But like you could test that, right? Power posing is like when people T-pose and things like this. They stand in front of the mirror and they're like, you're a lion. You're a lion. You're a strong, that kind of stuff. Essential oils and aromatherapy, pseudoscience, improve mood. What does that mean? I don't know. But like you can make a more specific claim, and I would say this is a scientific claim. Lavender oil can cause gynecomastia in pre-pubertal boys, is a scientific claim, and you can test the effects of excessive amounts of lavender oil on 12-year-old boys and see if they grow boobies, which I actually think that is actually true. Cupping. Anyone know what cupping is? Anyone do cupping? I had somebody in the 8 o'clock class do cupping. That's somebody's skin, by the way, up in the thing here. So it makes it look like you got into a fight with a racquetball and lost. It looks like you had a really rough day at the racquetball court. What they do is they like suck your skin up. In high school, you're arranging seats. What's your sign? Yeah, that's a thing. Lots of people believe in astrology. Grandmother has done it. Yeah, I'd say fight with an octopus. Yeah, giant squid. They're cracking. Yeah. So it's sucking your skin up into these cups here, and basically a lot of swimmers in the Olympics were doing cupping. I just don't want my skin to look like that. Like it's just purely a cosmetic thing. My personal trainer swore by it, but there's no scientific basis for it. The NCCIH, by the way, that website I just had up there, is the National Center for Complementary and Integrative Health. So it's actually a branch of the NIH that actually takes alt med questions seriously, and they run experiments to see, hey, does this alt med stuff work? And there's to flip hats for a second. there's a lot of people that say, well, alternative medicine is all pseudoscience because there's no research basis for any of it. If it had a research basis, we would call it medicine and not alternative medicine. And that's actually not true. The definition of alternative medicine by the WHO and the NIH and NHS and things like that is alternative medicine is things that are sort of like outside mainstream medicine. It doesn't mean they don't work. It just means it's not what's traditionally done when you go see a doctor. A doctor usually is not going to give you willow bark tea for your pain. They're going to give you Advil or aspirin or something like that. But aspirin derives from the bark of a willow tree. So there's probably some. I don't know if it's effective enough. Willow bark tea. I don't know if it's effective. Nature's aspirin. WebMD. Salicin, similar to aspirin, has pain and fever reducing effects. Don't use it for COVID-19. There's no good scientific evidence to support most of these uses. Let's see here. Seems to reduce lower back pain. Okay. So, yeah, I mean, like the active ingredient in willow bark tea is essentially aspirin, right? Like that's, I think, where aspirin is actually derived from. So it stands to reason that like it would work. I don't know how effective it is or anything like that. But like it's alt med because like when you go to the doctor, they don't give you willow bark tea. They just like, here, just let's cut to the chase and take the pill. So there is kind of a misnomer, and Wikipedia is actually wrong on this topic. It's something that's actually bugged me before, where Wikipedia actually ignores the actual definition of things from like every government agency and just has its own definition on there. Where alternative medicine is defined as alternative to traditional techniques, but they say it's. Let's see if it's actually changed. Despite lacking biological plausibility, right? And so, like, it's biologically plausible that willow bark tea would have the same effect as aspirin. Does not matter to the Wikipedia editors. Doesn't matter. Like I actually like posted like the definitions from like 13, government agencies saying here is the definition of alternative medicine for you. It does not matter to them. Like Wikipedia just does not care. They have their own definition. It's one of the problems with Wikipedia, honestly. So yeah, like a lot of alternative medicine is pseudoscience, but it's not equivalent to it. Because the NCCIH actually will do a scientific study and be like, all right, does this thing work? And I've actually gone through, like when my wife was at UC San Francisco, like they had a collection of papers on what alternative medicine things work, which ones don't. Most of them don't work, but some of them do. And so it's a misnomer to think that no alternative medicine works, because there is like I said, a branch of the NIH that's dedicated to just doing studies on that topic. So. That was crazy. After I told her I was Leah, she said, "Good, I can trust you." That's funny. Yeah, it's funny. So yeah, so like if you swear by cupping, more power to you. Like, it's probably placebo effect, but placebo effect is real. So knock yourself out. People can be allergic to Wi-Fi is pseudoscience. They've done experiments where they put people into a room with the Wi-Fi router turned off, and they're like, like, bro, the thing's not even on, and it doesn't change your mind, right? And that's a sign of pseudoscience. Like, it doesn't matter. You can show them, like, look, the thing isn't even turned on yet. Like you all were complaining about getting migraines from 5G, and the things weren't even powered on. Like you're making stuff up. It doesn't matter. They believe what they want to believe anyway. That's pseudoscience. Okay. ESP is real. You can probably test that scientifically. You do the cards and things like that, but there's pretty good evidence. There's, people don't have the ability to like television. No, that's not right. Remote viewing. I don't know. Who knows? But you can test it. You can definitely do an experiment and test it. Stock prices use Gaussian curves that fluctuate up and down. That sounds scientific, right? In fact, it's the basis of the Merton-Scholes algorithm. Turns out to be wrong, and people still believe in it despite it being shown to be wrong. So it's pseudoscience. Yeah. So we could keep going, but like you kind of get the idea, I think, right? Where like uh, pseudoscience, the demarcation, according to Popper at least, is that pseudoscience can't be disproven, right? Like even if you come out with a negative result, like they won't accept it, or they'll change, like they'll just be like, well, we weren't talking about that element of health when we said, it improves your health. We were talking about this element of health, and it's this slippery, nebulous kind of thing. But like, some things that sound completely implausible turn out to be, true. Like there's like peppermint oil is one of the best treatments for a lot of GI conditions. It sounds like pseudoscience. It sounds like alternative medicine, right? Oh, just take peppermint oil and it'll help with your irritable bowel syndrome. Turns out it's true. There's actually I was reading a paper. It's like they were comparing the top 5 treatments of IBS, and because I read scientific journals for fun, like it's a weird hobby I have, and I was going through and one of the things was like peppermint oil, quality of research, A, effectiveness of the treatment, A. I'm like, oh, look at that. Like, I would not have expected that result, but there it is. It sounds like something that your crazy aunt tells you. Just take some peppermint oil and you'll be better in the morning. And turns out there's good scientific research for it. So you can't base these things purely on what it sounds like, right? Like a lot of people are like, well, salt dissolves in water. That sounds like science. SSRIs relieve the symptoms of depression. That sounds like science. Zodiac, that doesn't sound like science, but it's more to it. There's more to it than that. The main thing is the falsifiability criteria, at least according to Popper, which is the notion that you could show that it's wrong. Okay. And zodiac signs, you can't show that they're wrong. No matter how many times you do a study, they don't admit that they're wrong. Okay. Saul Goodman's brother. Somebody was mentioning that in the previous class too, Better Call Saul or something like that has somebody that is into the pseudoscience or something like that. I don't know. Borax can be used to help extract gold from ore. Can be used to make slime with Elmer's glue. The fire retardant kills ants and colors fireworks with green color. I think all that's actually true. I think those are all actually scientifically valid statements. Even. Yeah. So for your quiz today, I'm going to put up a couple things, and you need to determine, are they science or are they pseudoscience? Okay. So hope you guys had fun today. We're going to continue our discussion of science on Friday with the replicability crisis, the replication crisis, which is a fun crisis in science that started a bit over 10 years ago, I'd say, and is still going on today. So we'll talk about that. All right. Peace out, you guys. Bye.